Is die vooruit?
Die zou ik niet gebruiken. Ik zou die gebruiken.
Deze?
Want daar staat de tripod net tegen.
Still not working. Oh, it's working. Okay. Hello everyone, my name is Maria and this is Lawrence, and we would love to welcome you all to HART's very own first showcase, Engineering in New Sense. And before we go into all the awesome stuff we did in the past year, we want to share a little bit about our vision and history.
Yes, thank you all for being here. Team HART. HART stands for Human Augmentation, Research and Technology. So let's start off with the question, what is human augmentation? Well, your brain, if you're a human being, it understands the world through your 5 biological senses. For the rest, your brain is left in the dark. It figures out the world only through the signals which come in through these 5 senses. But it also means that you are constrained by the limits of these senses. And human augmentation is the field which tries to alleviate these limits and allow you to feel different information than comes in through these 5. At HART, we try to do exactly that. We've developed a sleeve with vibrational motors in it, which can represent all sorts of information. Through artificial intelligence and mathematical modeling, we map information, general information, to patterns on your sleeve where they vibrate. And with this, we can, in a way, engineer a new sense. Our eventual goal, our long-term vision, is to build a sort of universal platform where you can easily download and install new senses. Think about it as a sort of app store, but then, for human augmentation. Today, we're going to tell you what we've done last year, and for that, I think it's nice that we start at the beginning, so I want to give the word back to Maria.
Thank you. So in the summer of 2020, I got up together with 5 other students on the idea to set up a team focused on human augmentation. So we made a pitch to the university, wrote an extensive blueprint, and by the end of November, we were an accredited student teams. And a few months later, we onboarded the first generation of students. One of them was Lawrence here, and we got to work. So now with a team of over 20 people, we developed the platform that Lawrence mentioned, which requires a lot of research that we also do while spreading awareness about human augmentation. So our prototype and our platform requires information to be transferred into vibrational patterns. But before HART, all of these phonemes and vibrations were handpicked. Or they followed naturally from specific kinds of data. And clearly this approach is not scalable, but it really needs to be if we are to realize our vision. And it requires extensive research in various domains. So over the last year, we started developing a mathematical model to tackle this problem in an analytical way. And last month, we presented this poster. It's our first results at the European Flagship Human Brain Project Summit. And currently, we're engaging in research to generalize our approach even further to fit all kinds of data. And besides our own research, we want to spread awareness about other work fostering the new applications and new fields, maybe subfields of human augmentation. So that's why we also organized events, for example, like this. And last year, we did 2 big things in this area. First of all, we organized a symposium. It was called Transhuman Race, and we invited world-class speakers, including researchers from MIT and Oxford. They shared their work on futuristic technologies and discussed current trends in human augmentation and related fields with us. And secondly, we participated in TV contest, which is a competition organized by our own innovation space for engineers with international ambitions. And we won this contest in the student team category. And now let's get to the meat of this presentation. It's called Engineering in New Sense, right? So we want to develop this platform. But we knew that to convince you that our vision is feasible, we needed to show you a tangible implementation. And for this, we chose a language barrier. So we thought, what if you could understand any language in the world while it's being spoken?
As I told you before, we've developed a sleeve, and we are developing a sleeve which holds 24 different vibrational motors. These vibrational motors can represent all sorts of information, but for this prototype we are focusing on language. So the microphone picks up spoken language, which is then transformed into these patterns. Words are made up of sounds. We call these sounds phonemes. In the English language, there's 39 different sounds which make up words. Every sound has a different corresponding pattern, and these patterns can then be displayed on the sleeve. Before we show you our prototype in real life, right here, we'll talk you a bit through our iterative design we've gone through over the last year. But for this, it's important to show where we started. A big inspiration for our team is a paper by Dr. Reed. In this paper, they also developed a sleeve with vibrational motors. Some of the pictures you can see here behind me. And we are working on top of their work. But there were some issues with their prototype, mainly three things. First of all, it was very bulky. The electronics used to power this device were actually about the size of a big gaming console. So it's not quite a wearable device for everyday use. Second of all, it's quite expensive. The total cost of the hardware comes down to around 2,000 euros per unit, which is too much if you want to scale it up. And then lastly, I hope you agree with me, it is not the prettiest device either, so we thought we might as well tackle that. We started off with a very no-nonsense prototype. In this prototype, we used the vibrational motors, were very similar to the ones which are in your phone, which make your phone vibrate when you get a notification. And we hooked these up to a simple microcontroller, an Arduino, very basic stuff, which was then wired up to a laptop for power and control. These motors were put into sockets, small sockets, which were sewn into the fabric of the sleeve. You could put on the sleeve and we had the basic functionality down. With this we could play a few patterns and a few distinguishable phonemes right on the arm. But there were some problems with this prototype as well. The first of all is that the vibration motors we used did not have the accuracy that we required. We want to have a wide range of patterns, but they take a second to speed up, and this really slowed down the functionality. It takes a second for these vibration motors to get up to speed. And we also had only one variable to play with, which was intensity, and we needed more. Second of all, the sleeve was too elastic, meaning that if you would put it on a few times, there was a big chance you would accidentally rip out a motor or the wiring. So we moved on to our second iteration, V2 of our prototype. V2 had the following main improvements. First of all, we switched to tectonic exciters instead of the standard vibration motors. Tectonic exciters are basically small speakers, and they speed up very quickly, and you can actually have two variables to play with now. You can talk about intensity, so amplitude, or frequency. And this allowed us to have a wide range of different patterns, which can represent a wide range of different information. In this case, phonemes worked very well. They did require quite a lot of power and some issues to control, so this came with a lot of electronic overhead. As you can see, that's a lot of wires. Secondly, this power need was a concern because we wanted to make a wearable prototype. So we needed to make sure that it actually was able to run on batteries, and we figured this out. So this was one important step towards a more accessible prototype. Then another innovation we used in this prototype was the motors. On the motors, around the motors, there's now a 3D designed casing, which was then glued onto the fabric, and this way we have way less issues with wires being pulled out while turning it on and off, or while putting it on or off. There were also issues with this prototype. First of all, it's quite messy, so that means if you have a lot of wires, there's a lot of wires that can come loose. So it was not that reliable and not that robust. And then secondly, if you have a sleeve which you want to have snugly fit around your arm, you need two things. You need it to be flexible in width so that lots of different sizes of arms can fit in it. But at the same time, it shouldn't be flexible in length, because if it's flexible in length, then it means that the relative position of the motors on your arm changes every time you put it on, and that makes it exponentially harder to actually learn these patterns and learn how to interpret these patterns. So to solve these two issues, we moved on to our last version of our prototype. First of all, we looked into developing a 3D fabricated, a 3D printed fabric, which you can see behind me. We went through a couple different designs and we ended on this fish scale design. And the way this design is laid out makes sure that it is exactly only flexible in width and not in length. The motors and the 3D cases were then put on this fabric, and over this there was the normal fabric of the sleeve. And secondly, to get rid of the wire issue, we designed and printed our own PCBs. We went through a few different iterations, and this really helped with making the prototype more reliable and more accessible, and just more robust in general. And we also added Bluetooth, which makes the prototype truly wireless, and in this way, wearable. So what do we have now? We have a prototype which consists of 24, I will say it once more, vibrational motors, which can display a wider range of information through haptic patterns, specifically these 39 phonemes. It is wireless, it is wearable, and it hooks up to, or it connects to a laptop, which has a training software environment through which a user can quickly learn to interpret these patterns. The software also stores the information on the activity of the user, so we can get insights on what's the best way to learn to interpret these feedback. I think I've talked enough about the development. It's time to just show you. Please give it up for Lisa.
See, I'm here. Okay, hi guys, I'm Lisa. I joined HART last September, and I had a great opportunity to become one of the first users of our prototype. And I'm just going to talk you through my experiences. How did I learn a new vibrational language? And yeah, how did it went? So, as you can see, I'm wearing this sleeve right now, but that's not the only thing. We also have our software. This is self-made software, and it is actually the platform where I was able to learn this vibrational language. So yeah, I need to start with the basics. I never started to learn a vibrational language, so it was the first time for me as well. And I needed to start with the phonemes. I needed to know, as Laurens told you, every phoneme has its own pattern. And I needed to know which pattern was related to which phoneme. So I started in our software. I was able to choose over here which phoneme I wanted to feel, and I was able to send it. Now, you're not feeling anything, of course. I'm feeling something. So I'm going to show you what I actually felt. That's the feeling of the phoneme A. I hope you understand a bit better what I'm talking about then. So yeah, I started doing that, just trying to feel which pattern was where and how I should interpret this. I did it for a few phonemes. And then I went to force identification. This meant that I was able to select the phonemes I wanted to train, and then the software would randomly send one, and I had to guess which one it was. I again will show you an example. For example, I had these two phonemes. I would send them. For example, this was Z8, and you see I was right. It turned green. This was an immediate feedback system for me to know if I was actually capable of guessing which phoneme I was feeling. At the beginning, this went very funny in my brain. I needed to remember these patterns, and my brain started to make mnemonics. A good example is A, the one you just saw in the animation, AH. It reminded me of a ghost. As in when a ghost scares you, you go like, ah! And it travels in a bit of a curved way for me. So every time A was displayed, I was thinking about a ghost. When time goes on, and I was repeating it quite a lot, those mnemonics faded away, and actually became automatic. As you guys are not thinking about hearing me right now, and I'm not thinking about seeing you right now, I was able to unconsciously think which phonemes were presented on my sleeve. And that's actually something called brain plasticity. This is the ability for our brain to rewire our connections based on external signals. I personally, this can be done within a few hours of training, and I personally think that my brain rewired something, because I don't have to constantly think about it anymore. When it's displayed, I immediately know which phoneme is presented. So it was really interesting to experience. So I had all 39 phonemes around a few weeks, and I needed to go to words, because this is not something we can communicate with. We need words, we need sentences in order to really communicate with someone. So that's also possible in our software. I would go to words. Words was a new level of difficulty, as I can say. Not only I had to view the phonemes, I needed to view it better. I needed to translate in my head which phoneme it was. And after that, I also need to think about pronunciation. You may understand a word is maybe written differently than it's pronounced. For example, phone, P-H-O-N-E. When you pronounce that, it's only 3 phonemes. It's F-O-O-N. I needed to develop a new way of thinking before I could actually understand this communication technique. So I will show you a bit how this actually worked. I was able to select some words, and in a second I will choose again force identification, so it will send a random one. I will be a bit quiet, so I need to focus still a little bit. So yeah, here we go. Well, this is the funny thing about live things. Sometimes things go wrong. Currently, I think we have an error in our system. Yeah, as you can see over there. It's still a prototype, so sometimes the software has a problem. I'm just going to restart it. It works again. So we're with the words. Again, I'm going to select the words. Now you go to forced identification. I think this was the word purple. Let me see. I was right. Again, you guys aren't feeling anything. You just have to take my word for it that I was actually feeling purple. So I'm still, again, I have an animation for you guys. Over here, let me see the purple. Oh, sorry, wrong. Open system. Here we go. Again, you can already see. I hope you understand. Sorry. Here we go again. So yeah, I hope you can understand a bit better about what we're talking about, phonemes and patterns and words. So where I am now with my training, I'm able to understand simple words. Think about maximum of 7 letters, and it's just still a process. I need to apply this new knowledge of phoneme patterns to the new words and need to interpret them step by step. Of course, this is not our vision. Our vision is that we can communicate with someone in real life. We want someone having to talk to me, and I can just, on the moment, understand what they're saying. And that's something I want to explain with you with Maria on my side. So I can ask Maria back on stage.
Hello. So I was born and raised in St. Petersburg, Russia. And ever since I moved to the Netherlands, I sometimes miss interacting in my native language. So if I say, Lisa, can my family be my keyboard? I don't think you would understand me, right? So let's see how our prototype would help with that. First, my Russian sentence would be transferred into the cloud, where an AI algorithm would transcribe it and then translate it into an English language. Then it will be sent back into the prototype that Lisa is wearing, and all the words that were translated would be decomposed into the phonemes, and then these phonemes would be correlated to the vibrations that then would play on your forearm. So with that, Lisa, what did I say to you earlier in Russian?
Maria just told me that I'm her favorite cyborg. Maria, you're my favorite human.
Oh, good. So for this, I would like to invite Julia on the stage, and she will tell you more about our outlook on the future.
Hello everybody. So now that we have discussed everything that we've achieved in the past year, we can reflect on what we have learned. So what conclusions can we draw? We have proven that we are actually able to augment the human sense, as Lisa is now able to interpret language almost without thinking about it. But there's still a lot of work ahead. So I will quickly walk you through our ambitions and plans for the upcoming year. Lisa's training has shown us that the prototype is in a state where it can effectively be used for testing. So now we will continue with extensive user testing, both inside and outside of the team. With this, we will iron out any remaining bugs and inefficiencies. And we will also get real interaction insights. The main goal of this user testing will be to find out about the effectiveness of the different training programs and the user insights. Moreover, we will still want to continue to improve the prototype, and this will mainly be focused on evolving the software for the use in less controlled environments. So, as we mentioned before, research is also one of our main focus points, just as the prototype and awareness. We are actually already developing a mathematical framework which focuses on the transformation of data to patterns. And with these patterns, we can learn to interpret them. And we will continue this development by working together with both researchers and mathematicians, both at this university but also beyond. And this mathematical framework highly depends on neuroscientific research. So this is also something we will be focusing on. And eventually, we will be focusing on a general way your brain perceives patterns so that all different kinds of data can be included. Now, moving on to the societal aspect we want to focus on for the upcoming year. We want to continue to create enthusiasm for human augmentation through our awareness activities. We also want to build an active community. Moreover, we want to build partnerships with businesses, and we want to explore the applications of our prototype aside from language. So, now I think that we've discussed everything that we have achieved in the past year, and everything that we will be working on in the upcoming year. I think it's time to wrap up. So I want to thank you all very much for coming, but before you leave, I have two more things to say. To the students here and to the people watching at home, if you're interested in joining our team and want to help build our vision, go to teamheart.nl/recruitment or come to our online recruitment event on Monday together with Fruitpunch AI and Serpentine. And secondly, if you want to see our prototypes up close and want to experience yourself what it's like to feel language, you're able to walk up to the stands on your right and experience it. Well, we want to continue to help bring human augmentation to its next levels. We hope someday we'll become more than human. Thank you all and have a nice day. Okay, so you're free to also ask any questions to any of the HART members, which can be recognized by the t-shirt as well. And feel free to come up to these stands.
I thought you were going to bow. That was really well done. Kunnen we dat goed hebben? Mogen we dat goed zijn?
What? I was like,
Cool.